In this video, you're going to be introduced to some of the basics of units in physics and how to convert from one unit to another. We'll start out with the standard units of measure. For time, we always measure that in seconds. Distance is measured in meters, and mass is measured in kilograms. Some people kind of forget about that kilogram being our standard unit of mass because it has a prefix in front of it. But kilogram is considered the standard unit, which means it's the unit we'll need to convert to when using mass in problems. Here's a table that includes the unit prefixes that you'll need to know for physics. For the most part, we'll focus in on, we'll use centi, milli, and kilo the most, but in second semester especially, we'll see some of those smaller prefixes like pico, nano, and micro, as well as some of those larger ones like mega and giga. When we're converting our units, we need to make sure that we're using dimensional analysis. We'll do so by placing the value, like you saw in this previous chart, beside the standard unit, and we'll put a 1 beside the prefix. Also, you want to make sure that your final answer is in scientific notation if it is greater than 10,000 or less than 0.001. So let's look at some examples. In this first example, we're converting from 350 kilometers to meters. So we put 350 kilometers divided by 1 times 10 to the third meters in 1 kilometer. I knew to write that 10 to the 3 next to meters because kilo as a prefix stands for 10 to the third. The way that we'll do our unit conversions is we'll always put that 10 to the whatever power next to the standard unit and then a 1 next to my unit with my prefix. When I do this calculation, I find that I get 3.5 times 10 to the 5th meters, or 350,000 meters. Here's another example. We're converting from 0.025 microseconds to milliseconds. When we're doing this conversion, we'll first convert from 2.025 microseconds into seconds. You'll see that on your screen here. We went from 0.025 microseconds over 1 times 10 to the negative 6 seconds divided by 1 microsecond. I put that 10 to the negative 6 there because micro stands for 10 to the negative 6. I put 10 to the negative 6 seconds, 10 to the negative 6 next to seconds and a 1 next to microseconds. Then I'll convert from seconds to milliseconds. So I put a 1 next to the milliseconds in the numerator there and 10 to the negative 3 next to seconds. I find out in that conversion that I end up with 25 milliseconds. One final example. I have 2 more examples. We're going to convert from 16 kilometers per hour to meters per second. This is a conversion that you will likely be doing within the first few units in physics. We start out as writing it by 16 kilometers in 1 hour. We're going to convert from kilometers to meters first by multiplying by 10 to the third meters over 1 kilometer. And then we'll convert from hours to seconds. Some of you may have memorized how many seconds are in an hour, but for those who haven't, I've converted from hours to minutes first by multiplying by 1 hour over 60 minutes. And then from minutes to seconds by multiplying by 1 minute over 60 seconds. When I do this calculation, I find that 16 kilometers per hour is equal to 4.4 meters per second. Lastly, I want to convert 140 centimeters squared to meters squared. To do so, I need to be aware that centimeters squared means centimeters times centimeters. That's how I've written it out at the beginning of this calculation. 140 centimeters times centimeters. Because that makes it clear that I basically need to do this conversion twice. In the first time, I have 10 to the negative 2 meters over 1 centimeter. And then I do that calculation twice to go from centimeters squared to meters squared. This is the end of this video introducing unit conversions. I highly suggest that you do some additional practice, which can be found on Mastering Physics.